In the previous video, we looked at the beginning stages of defining a class, and now we're going to add some methods to that class. So our class was for rectangle objects. Each rectangle object has an x and y coordinate for its upper left-hand corner, a width, and a height. In the previous video, we looked at the definition of this constructor method, and in theory that's all you need when defining a class. You could get by and you'd be able to construct rectangle objects, but they wouldn't be very useful. So let's keep in mind that this is a class and we cannot use it on its own. It's going to be used in the context of other code, other client programs. Here's an example of a client program for our rectangle class. You can see it starts out by constructing two different rectangle objects, storing the reference to one of them in the variable r1 and storing the reference to the other in the variable r2. It then prints the dimensions of r1 along with its area, and you can see it's computing the area itself by multiplying r1.width by r1.height, and it then prints that result. It does the same thing for r2, printing the dimensions, computing and printing the area. It then grows both of the rectangles, increasing their dimensions by some amount, and then it prints the new dimensions. And you can see the client is doing most of the work here. It's not relying on the rectangle object to do much of anything but hold the attributes. But what we'd like to do is give the rectangle object the ability to do stuff, and then the client program will become simpler. So for example, we might want the rectangle objects to be able to grow themselves, and we can do that by adding a method called grow. So this is a new method in our rectangle class. It's also indented underneath the class header. Like any other method, it has to begin with that special parameter self, and then you can have other parameters, in this case dWidth for the change in width, dHeight for the change in height, and you can see that we're using those inputs to change the width, increasing it by dWidth, and to change the height, increasing it by dHeight. So this is going to modify the attributes of the rectangle on which it is called. And notice we're using that special parameter self to access the attributes, to access the variables that are in the object. Now let's see how we would call the grow method on the rectangle r1. So here's what r1 looks like before calling grow, and now we're going to call grow using dot notation. So r1 dot grow, and again that's because the grow method is inside the object given by r1. And what's going to happen when we make that call is the inputs 25 and 100 are going to get passed in for dWidth and dHeight. And then the value of self actually comes from what comes before the dot. So the value of r1, that reference, is going to get passed in to self. As a result, when we say self.width, we're going to be referring to r1's width, and self.height, r1's height. And that's why we're going to end up changing what's inside that object, increasing the width by 25 and the height by 100. And we can see that by now looking at r1.width, it'll now be 125, r1.height will now be 150. Another method you might want to have is one for computing the area of a rectangle. So here's what that method definition looks like. It only needs the input for the self. It doesn't need any other inputs. And it's just going to return the result of multiplying self.width by self.height. Now let's say we have r1 and r2, which we've already seen how to construct earlier. If I say r1.area, this method is going to get called on r1. So self is going to be r1, it's going to be a copy of that reference, and so I'll get r1's area, which is 100 times 50 or 5,000. If I call area on r2, then the self parameter is going to get a copy of the reference in r2, and so I'll get 20 times 80 or 1600. And you can think of these calls as asking the rectangles to give us their areas. And it's worth noting that there were no inputs in the parentheses here. The only parameter is the self parameter, and that comes from before the dot. No other information needs to be passed in because all of the necessary info is in the object itself. Now that we've added those two methods to the rectangle class, we can simplify our client program. So if you remember, the client program computed the area of R1 and then printed the result of that computation. But now that we have the area method, we can just call that area method and take whatever it returns and print that. So the client doesn't have to do that work itself anymore. And we can do the same thing down here with the area of R2. And then when it comes to growing the rectangles, we can go ahead and call the grow method and let it do the work. And so our client is now simpler than it was before because we've pushed that functionality inside the object and we're letting it do the work for us. When we have a method like grow that modifies an object, it isn't necessary for it to return anything. And the reason is it's actually changing the internals of the object, and those changes will still be there after the method returns. To see this more clearly, let's trace through an example and look at what happens in memory. So we have our global stack frame. We start out by constructing our object, and what gets stored in R1 is a reference to that object. The object is not in the stack frame, it's somewhere else in memory, and what's in the stack frame is a reference to that object. It's the memory address of that object. Then we call the grow method, and so we get a stack frame for it. dWidth and dHeight get the values that are passed in. Self gets a copy of what's in R1 because R1 is before the dot, and so it ends up referring to the same object. We haven't passed in a copy of the object, we've passed in a copy of the reference. And so when we go ahead and change the width and the height, those changes are changing the only rectangle object we have here. And so when the method returns and its stack frame goes away, those changes are still there, and we see them when we print the dimensions.